Today's supply chain struggles have been creating issues with food starch availability. As a result, companies are investigating ways to either extend or replace starch altogether in a variety of food products. Starch is considered a workhorse ingredient due to its hydrocolloidal properties, including viscosity, emulsification, gelling, and suspension. Citrus fiber is probably not the first ingredient that comes to developers' minds when looking for ingredients with comparable benefits. However, some citrus fibers on the market, such as Citri-Fi, can deliver many beneficial attributes that allow starch extension or replacement to be possible in a variety of food products. First, we are going to discuss the similarities and differences between Citri-Fi citrus fiber and starches, such as modified starch and clean label starch. Then we'll dive into the specifics on how to use Citri-Fi to target certain functionalities. And we will wrap this up with a few case studies that demonstrate some successful food applications. As mentioned, starches provide a wide array of functional benefits depending on the type of modified and clean label starch. Here we list some of the top line benefits. As you can see, Citri-Fi citrus fiber can provide almost all the functional attributes compared to starches. In many cases, Citri-Fi's high water holding and emulsification properties allow this natural fiber to be stable in most food processing conditions. Citri-Fi also is used at lower usage rates versus starches. There are some key differences between citrus fiber and starches. For example, hydration time and water content is important when activating Citri-Fiber's full functionality. Citri-Fi creates viscosity in the presence of water and remains viscous through the food process. If additional viscosity is needed, shear conditions such as homogenization will open up the fiber to build creaminess and viscosity. Because of Citri-Fi's high native intact pectin, this natural ingredient can provide gelling properties similar to extracted pectin. To activate gelling, Citri-Fi needs to be in a low pH and high Brix conditions. Citri-Fi's natural composition of insoluble and soluble fiber in the form of pectin and some protein enable it to provide multiple functionalities without chemical modification. To extend or replace starch, first we need to understand the objectives that the starch is delivering to the food product. Do you need viscosity? Or do you also need emulsification? Next, we need to consider the food processing conditions used. This is important since we mentioned previously, water content and hydration time are key to fully activate Citri-Fi. And when creating gelling properties, we need to understand the processing conditions so that we can create the correct environment when activating the native pectin to gel. Starches are well known for the ability to create low to high viscosities, depending on the modified or clean label starch used. To increase viscosity, we have several Citri-Fi options available. As mentioned, shear opens up the fiber to create additional viscosity. One option is to use a homogenizer at a minimum of 100 bar or 1500 psi. Another method is to use a colloid mill. Citri-Fi 100FG or 140 are the best products to use when creating additional viscosity when using shear processes. The usage levels can also be adjusted to improve the viscosity. Another option is to use either the Citri-Fi 200 series, which is citrus fiber co-processed with guar gum, or the Citri-Fi 300 series, which is citrus fiber co-processed with xanthan gum. Though Citri-Fi provides emulsification properties, it can be enhanced by using high-pressure homogenization. Here we demonstrate an oil emulsion containing 2% Citri-Fi 100 Fg, 25% oil, and 73% water. Increasing the pressure increases the viscosity of the oil emulsion. The increase in pressure reduces the oil droplet size, which enhances Citri-Fi's water binding to build viscosity and creaminess. Here we demonstrate how different pressures affect Citri-Fi 100 Fg and M40. As the pressure levels increase, the Citri-Fi solutions become thicker. Citri-Fi 100 Fg is a slightly larger particle size versus the Citri-Fi 100 M40. Also, using 2 passes through the homogenizer helps increase the viscosity as well. To activate the gelling properties, Citri-Fi must be used in conditions where the Brix level is greater than 55 and the pH should be less than 3.5. The most popular application is bake-stable fruit preparations. We recommend either the Citri-Fi 100 Fg or the 140 for the best gelling. Dosage can range from 1 to 2% depending on the food application. You can also achieve different textures from pulpy to smooth by using different particle sizes. As you can see here, why it is important to use Citri-Fi in specific Brix and pH ranges. Here, the gelling properties reduce when the pH is higher than 3.5, even though the Brix is greater than 55. The lower the pH, the firmer the gel becomes. This graph illustrates the Brix and pH conditions needed to achieve gel strength. Brix and pH are strongly correlated. As mentioned, Citri-Fi provides emulsification. Citri-Fi's composition of pectin and protein binds 7 to 10 times its weight in oil. To demonstrate this, we've designed an emulsion stabilizing index to compare Citri-Fi versus other common emulsifiers, such as lecithin and mono and diglycerides. One of the popular demonstrations we like to do with our customers is the emulsion demo. Here we mix 15 grams of oil into 5 grams of Citri-Fi in a glass vial. During the mixing step, the fiber opens up and traps the oil. Then we add 50 grams of water and shake the vial to blend the 2 phases. This emulsion will remain stable for weeks. To understand Citri-Fi's emulsification capabilities, we created some micrographs. You can see the insoluble fiber, which is green, and the soluble fiber, which is blue, has trapped the red oil droplets to make a stable emulsion. This table lists some typical applications where Citri-Fi can be used while providing some of the benefits of modified or clean label starches. Applications range from baked goods to sauces. Now that we have a fundamental understanding of how Citri-Fi works, let's take a look at a few food application case studies. We will start with sauces and dressings. We recommend several Citri-Fi products in this category. There is the standard Citri-Fi citrus fiber 100 line, the 200 line, which is citrus fiber co-processed with guar gum, and the 300 line, which is citrus fiber co-processed with xanthan gum. Usage levels are half of the starch amount used. We recommend pre-mixing the Citri-Fi with other dry ingredients. However, you can also disperse Citri-Fi in oil before adding water. And if the Citri-Fi 100 is used, which is a coarse ground citrus fiber, you can pre-hydrate with some agitation. For the best results, homogenization or high shear is preferred. Here we have a formulation for a vinaigrette dressing. The Citri-Fi 100 was used at less than 0.6% to stabilize the emulsion. The same concept was used here in making a Caesar and a honey mustard dressing. The Caesar dressing used only the standard Citri-Fi 100, while the honey mustard dressing used the citrus fiber co-processed with xanthan gum. Both formulations used Citri-Fi products at less than 0.6%, which is a significantly lower usage rate versus modified or clean label starches. Here we compare two formulations of salad dressing. The customer's goal was to only remove the modified starch to clean up their label declarations. To do this, we recommended 1% Citri-Fi 100 FG. For this customer, xanthan gum could remain on the label, so we recommended keeping the ingredient in the formulation. Globally, customers use Citri-Fi to replace starches in a variety of sauces and dressings. Here, the customer labeled the functional fiber as citrus fiber. Other labeling options include dried citrus pulp or citrus flower. However, labeling depends on regulatory requirements in your region. Now let's talk about sauces, specifically tomato-based sauces. Tomato composition is very similar to citrus fiber composition. They both contain insoluble fiber and soluble fiber in the form of pectin. Tomato and citrus fibers are linear, frayed fibers with high surface area and entanglements. At the same time, both types of fibers create a natural mouthfeel. Producers traditionally thicken tomato-based sauces by using tomato fibers. However, availability and cost in use can create opportunities for other food ingredients to be used instead. One tomato extension strategy is to use starches and/or gums. However, these food ingredients do not create the texture and natural mouthfeel of tomato sauce. Depending on whether starch or gum is used, the texture could be thick and short or slimy and long. Here we demonstrate Citri-Fi's ability to create similar texture to tomato sauce without any additional ingredients. The green represents the cell wall fiber and the blue represents the pectin present in the tomato sauce. They both show how the fiber's structure is a flowing and continuous fiber network. Using potato starch or maize starch interrupts the fiber network, causing the fiber structure to be more spread out and less uniform. This disruption in the fiber network alters the tomato sauce to have a less natural mouthfeel and texture. Here we compare a ketchup formulation that contains starches and gums to one that replaces those starches and gums with Citri-Fi citrus fiber. Citri-Fi, when used at 2% in the homogenized sauce, creates a thicker and more natural texture versus the starch and gum version. Homogenization is key to creating additional viscosity when using Citri-Fi. For example, this tomato sauce contains Citri-Fi citrus fiber. By subjecting the sauce to shear, the Citri-Fi provides additional viscosity. Here you can see the colloid meal increase the viscosity versus the control with no shear. And the homogenized sauce created more viscosity versus the colloid meal. Another example is with barbecue sauce. Here we replaced 3.3% of functional waxy cornstarch with 1.5% of Citri-Fi. The Citri-Fi is added to the dry ingredients before being introduced to the liquid phase. When using Citri-Fi, the water was increased slightly. Once again, we recommend homogenizing to produce equivalent viscosity to starch. The last tomato-based example shows how we were able to replace 4% of starch with 1% of Citri-Fi. Here again, we increase the water addition when using the Citri-Fi. Citri-Fi is added to the dry ingredients before being introduced to the liquid phase. This demonstrates that Citri-Fi citrus fiber can replace different types of starches depending on the botanical source and modification. Besides dressings and sauces, starch extension and replacement also is an option in fruit preparations for bakery fillings and yogurt. Bake-stable fruit preparations sometimes use modified starches and/or gums to improve the thickness and texture. Here we use Citri-Fi 140 to replace the modified starch and gel and gum while still maintaining a thick and pulpy texture. The natural intact pectin of the Citri-Fi creates the gelling effect when it is in high Brix and low pH conditions. Besides the more natural texture, Citri-Fi is clean label and has no E number. This natural citrus fiber can be used at lower usage rates and improves the stability versus starch and/or gums. Now that you have an understanding how Citri-Fi compares to starches, let's review the key points. Citri-Fi provides similar benefits as some modified and clean label starches, so it is a potential solution when extending or replacing those ingredients. Before formulating, you need to identify the targeted functionality, viscosity requirements, and food processing conditions before selecting the Citri-Fi citrus fiber. Citri-Fi provides some thickness, however, to create additional viscosity, we recommend homogenization. This natural citrus fiber also provides emulsification. And in low pH and high Brix conditions, Citri-Fi can form a gel. This natural citrus fiber works well in bakery, dairy alternatives, frozen foods, fruit preparations, processed meats, meat substitutes, and sauces. Typical Citri-Fi usage level for most food applications is 1% or less. In some instances where additional viscosity is needed, Citri-Fi can be less than 2%, like in condiments and fruit preparations. Thank you for watching this video. If you have additional questions about this technology, you can reach out to anyone on this slide. You can also visit our website at www.fiberstaringredients.com, where you can find a host of information, including our video tutorials and usage guides. Thank you again, and have a great day.